Hi, I'm Craig Terblanche. Most of the AI conversation happening in boardrooms right now is a conversation about capability. Can the model do the task? How accurate is it? What does it cost per call? Those are legitimate questions, but they are the wrong first questions. They are procurement questions dressed up as strategy questions. The question that actually determines whether your AI investment survives contact with your organization is architectural. Not what can this model do, but what is the system this model is going to live inside, and does that system hold? Over the next 20 minutes, I want to walk you through 5 layers of enterprise architecture, show you exactly where AI is genuinely powerful, show you where it is structurally incapable of helping you, and then draw the governance conclusion that follows from that. The anchors on this slide are the map: technology, data, process, logic, and then the ecosystem. Look at the two sides of this slide because the entire argument is contained in the contrast. On the left, a single node, an AI-generated function performing a repetitive task, scale, isolated task. On the right, multiple actors, data pipelines flowing in both directions, external environments feeding in, a human governance layer sitting over the top. Scale, macro system architecture. These are not the same discipline. They are not even adjacent disciplines. Generating a function is a coding problem. Building a system inside an enterprise is an organizational design problem that happens to involve code. The failure mode I see repeatedly is teams who succeeded brilliantly on the left and then assumed that success would scale to the right. It does not. It cannot, because the constraints on the right are not algorithmic constraints. They are constraints of ownership, sequence, accountability, and dependency. So let me be precise about my claim. AI is highly capable at the micro level, genuinely, materially capable. It is not a silver bullet for macro system design. Those two statements are both true simultaneously, and holding both of them at once is the whole discipline. How many of your current AI initiatives are actually on the left-hand side of this slide? Here is the structure I want you to carry out of this room. 5 layers. From the bottom: technology infrastructure, logic and data, business processes, roles and stakeholders, ecosystem and environment. Notice where the label AI sweet spot sits. Layer 2, logic and data. That is not a criticism of AI. It is a specification of it. That is where the technology earns its keep, and it earns it very well there. Now notice what sits above it. 3 full layers of business context that are not technological in nature at all. Process, people, ecosystem. A functional enterprise system is built on a technological foundation, but its success relies on the 4 surrounding elements to orchestrate engagement. You can have a technically flawless layer 2 and a completely non-functional system because layers 3, 4, and 5 were never designed. That, in my experience, is the single most common cause of the pilot that works beautifully and then never goes into production. Nobody architected the layers above the sweet spot. The next 4 slides take each of these layers in turn. Let me be generous to the technology before I constrain it, because this slide is where AI genuinely delivers. This is a standard business data pipeline: source, ingestion, pre-processing, transformation, storage, post-processing, analysis, consumption. Every organization in this room runs a version of it. The highlighted points are the high-yield intervention points: data cleansing, data validation, decision logic. These are places where you have a rule, you have a high volume of instances, and you need the rule applied consistently and fast. AI thrives there. It executes specific repetitive interventions on data sourced from APIs, from databases, from web interfaces. The return is real and it is measurable. But hold the word I used: accelerant. An accelerant makes an existing process go faster. It does not decide what the process should be, who owns it, or what happens when it fails. Which brings us to layer 3. Calculations and cleansed data are meaningless without sequence. That sounds obvious said out loud, and it is routinely ignored in practice. A correct answer delivered at the wrong point in a workflow is not a correct answer, it is noise. A validation that fires after the commitment has been made has no value. The broader business process dictates the exact steps and the exact workflows required for the engagement to make logical sense. The process is not decoration around the algorithm. The process is what makes the algorithm mean something. And note the second element on this slide, exception handling protocols. This is where most AI implementations quietly break. The happy path was designed. The exception path was assumed. In any real enterprise, the exceptions are not the edge case. They are a substantial and permanent share of the volume, and they are almost always the share that carries the risk. So the design question at layer 3 is not, can the model do this step? It is what triggers this step, what follows it, and what happens when it does not resolve. Workflows do not self-regulate. An enterprise system requires role players and stakeholders to govern the rules of engagement, to manage exceptions, and to execute the tasks that algorithms cannot resolve. Look at the roles on this perimeter: process owner, system architect, compliance and audit, exception management. Every one of those is a named person with an accountability, not a function in a pipeline. And this is where I want to be very direct with a board. If you cannot name the human being who owns a given agent or automated decision, you do not have a governed system. You have an ungoverned one that has not failed yet. That is not a compliance technicality. That is the difference between an incident you can explain to a regulator and an incident you cannot. Layer 4 is the perimeter. It is what turns a working automation into an accountable one. Layer 5, a system never lives in isolation. Internal processes interact dynamically with external supply chains, with demand channels, with delivery logistics, with regulators, with community stakeholders. None of those things are under your control, and all of them change without asking your permission. This is the layer that AI planning most consistently ignores, and it is the layer that most reliably breaks deployments. Your supplier changes an API, a regulator issues a directive, a market data feed changes its schema. The model did not fail. The environment moved. True architectural design accommodates this broader environmental reality. It assumes movement rather than stability at the boundary. Practically, that means your architecture needs to answer a question your pilot never had to. What is the blast radius when something outside your organization changes, and who finds out first? This table is the summary of everything I have said so far, and I would encourage you to photograph it. Read down the 2 columns, target operation, single repetitive functions against multi-actor, multi-step workflows, core dependency, algorithm capability, against ecosystem integration and AP is. Note that shift. On the right, your dependency is not on the model at all. Primary value, speed and automation, against orchestration and logical engagement, historical equivalent, macros and scripts against the SaaS disruption. And the last row is the one that matters to this table's audience, risk profile, individual and low against ecosystem-wide and high. The catastrophic error is not choosing the left-hand column. There is nothing wrong with the left-hand column. It is useful and it is cheap. The catastrophic error is running a left-hand column initiative while carrying right-hand column risk because nobody made the distinction explicit. I want to take the temperature down for a moment because the argument I have been making can sound alarming, and it should not. Consider the transition to SaaS. Platforms like Salesforce genuinely revolutionized CRM and lead generation. They changed how a specific set of processes worked permanently. They never replaced the core business itself. The logistics remained. The legacy dependencies remained. The ecosystem context remained. AI follows the exact same pattern. Localized disruption at specific process integration points against a core that persists. That has 2 implications, and they cut in opposite directions. The first is reassurance. You are not being asked to rebuild your organization. The second is a warning. If disruption is localized, then value is localized, and so is risk. Which means the strategic work is identifying precisely which processes are the integration points for your organization. That is an architectural judgment, and it is not one you can outsource to a vendor demonstration. Here is where the 5 layers land. A complete contextual consideration of what a system actually is, from the core databases out to the supply chain logistics, is the only valid approach to enterprise AI. Governance is achieved by orchestrating the architecture around the AI. It is not achieved by managing the individual function. This matters practically because most governance effort I encounter is aimed at layer 2, model selection, prompt controls, output review. All of that is necessary and none of it is sufficient because the risk does not live at layer 2. The risk lives at the boundaries between layers 3, 4, and 5. So the question I would leave with this board is not, is our AI safe? It is this. For every AI capability we have deployed or intend to deploy, can we name the process it sits in, the person who owns it, the exception path when it fails, and the external dependency that could move underneath it? If you can answer those 4 questions, you have architecture. If you cannot, you have an experiment, and you should be honest with yourselves that that is what it is.